Our focus is, of course, to find the slope of the tangent line to a parabola f of x is equal to x raised to 2 minus 3x. At a given point, that is the point of tangency, 2 and negative 2. And after finding the slope of the tangent line, we will be finding the equation of the tangent line. Okay? So of course, before we're going to start this one, we have to specify the given that is necessary in our computation. So we have in here the given, the function parabola, f of x is equal to x raised to 2 minus 3x, and the point of tangency, that is the same as 0.2 and negative 2. So our unknown is the slope of the tangent line and the equation of the tangent line. Now, so that when we are going to get the slope of the tangent line now, we have to work on our working equation for the derivative or for the slope, that is our m, which is the same as the limit, okay? The limit of f of x plus change of x minus f of x. Okay, so this is our working equation over change of x, as your change of x will be approaching 0. Will be approaching 0. Okay, and so that when we are going to solve for that one, let's try to start now. We say the limit as your change of x approaches 0 of what? We have to remember that our function is, we have in here the function, okay? F of x is equal to x raised to 2, x raised to 2 minus 3x. So that the first element in here, or the first mean wind in here, will be this one. The value of x is x plus change of x. So we just replace this x raised to 2 with this one. So that is the same as saying x plus change of x, of course, that is raised to the second power. Okay, minus raised to the second power, minus 3. Okay, what is your x again? Our x is the same as this one. Okay, so that is the same as x plus change of x. Okay, we're not yet done. Of course, this is minus the function f of x. So what is the function of f of x? What is the function f of x? We have in here the original function, that is x raised to 2 minus 3x. Okay, so that is how to do them. Parenthesis over change of x. Now with that, we can not make use of the direct substitution in here, because if we do the direct substitution, it will make the denominator 0 and it will turn the limit to undefined. So how is that? We are going to simplify. Okay, so we will simplify. So we have in here the limit as your change of x as it approaches 0. So this one will simplify. So that is the same as x raised to 2, x raised to the second power. Okay, and then what is the middle term of this perfect square binomial? That is the same as 2x change of x. How about the last term of the trinomial? That is the same as change of x raised to the second power. Okay, minus multiply, multiply that one, distribute, so minus 3x minus 3x. How about this one? Distribute, minus 3 change of x. How about in here? Distribute, negative x raised to 2. How about this one? Positive. Okay, it will be give you positive 3x, and over the change of x. Now notice again that after having now the expansion of these terms, you have to evaluate if there are variable that is to be cancelled. So notice that this one, x raised to 2, can be cancelled. Why? Because it has the opposite in here. Okay, negative x raised to 2, and that is 0. Okay, now what about in here? Negative 3x, that is also positive 3x, that can be 0. Okay, that can be 0. So with that, we'll be having a new form, that is the limit as your change of x is approaching 0 of what is left. We have in here 2x change of x plus change of x raised to 2 minus 3 change of x over change of x. Notice that still you cannot have the direct substitution, but in here you will notice a common factor. So we have change of x, change of x, change of x, so that if they have common factor, we can factor out that one. So we have another form, the limit as your change of x is approaching 0. Okay, factor out. So we have factor out the change of x. What remains inside the parenthesis? We have 2x. Okay, plus change of x plus or minus 3. That is over change of x. Notice again that we have common factor in the denominator and numerator, which is the same as 1, or to be cancelled out as 1. So we have now a form of limit. The limit as your change of x is approaching 0 is what? 2x plus change of x minus 3. With that, we do not have now the denominator, and so we can have now the direct substitution. So we will try now to do the direct substitution. Of course, if we will substitute, we will remove now the notation limit. So that is the same as 2x substitute plus change of x, which is 0, minus 3. And so you have now 2x minus 3, which is the derivative or the slope of the tangent line. So this is the same as the derivative or the slope of the tangent line. Okay, so we have now in here the result. Now it is because that is the slope, we have to specify where is the location of that slope of the tangent line. Definitely that is located at the point of tangency. And so what is that point of tangency? We have point 2 and negative 2. So that having the point of tangency, we can have the value of the slope of the tangent line. Okay, having said that one, our slope now is m is equal to 2 multiplied by what is the value of x. In here, use the point of tangency, that is the same as 2 minus 3, and so the result would be, what is that? 1. So the point of the slope of the tangent line at point of tangency is 1. Okay, it is 1. So that is the slope of the point of tangency. Now, after having now the this one, the next thing that we are going to have will be the equation of the tangent line. And so how are we going to get the equation of the tangent line? The equation of the tangent line is by using by using the point slope formula. Okay, we have to make use of the point slope form. Okay, so this is another form of linear equation. So what is that form? What is the form? We have in here y minus y sub 1 is equal to m multiplied by x minus x sub 1. So that is the point slope form. So that when we are going to use this one, we need to have the value of this coordinate. Now what is that coordinate? That coordinate is actually x sub 1 and y sub 1 is actually the point of tangency. That is actually the point of tangency. So what is the point of tangency in the problem? Our point of tangency in the problem is 2 and negative 2. Okay? Definitely, we have now the point of tangency. Another one that is needed to use this slope point form is the slope. We have already computed the slope. So our slope is already computed. That is the same as 1. So 1. Now having this element, point of tangency, and then the coordinates, point of tangency, and the slope that we have already computed, then we can have now the equation. Okay, we can have now the equation of the tangent line. So how is the equation of the tangent line? Now make use of the point slope form. So how is that? Let's try to have what is your y sub 1? Y sub 1 is actually negative 2. Okay, negative 2, and equals to what is your m? That is 1. Now multiplied by the quantity x minus x sub 1, that is the same as 2. So that you will notice it will give you now a result of distribute, that is 1 multiplied by this quantity x minus 2, that is x minus 2. Having said that one, how about in here? That is y plus 2. Now isolating y, it will give you now y is equal to x minus 2. Transpose that one, it will give you minus 2. So your y now is equal to x minus 4. So your y now is x minus 4, and this is now the equation of the tangent line. So the equation of the tangent line is y is equal to x minus 4. Now having said that one, we are now ready to graph the problem. So before we're going to graph the problem, we have to identify this one. So what is this? This is now the slope of the tangent line, at the same time slope of the curve, and the curve at point of tangency. So one is actually slope of the tangent line and the curve at point of tangency. And of course, what about this y is equal to x minus 4? That is now the equation equation we are computing. Equation of tangent line. Okay, equation of the tangent line. So we are now ready to graph the problem because we have already computed the derivative of the given function and computed for the slope of the tangent line, and we have already the equation of the tangent line. Okay, so let's try to make use of another paper. So we have in here, okay, we have in here, so that if we're going to graph the parabola, now notice that we need to go over with our parabola. So what is our parabola? So we have in here, our parabola is f of x is equal to x raised to 2 minus 3x. Now it is without limitation, so without restriction. So meaning we can just consider a value to be all real numbers. So may I make use of some of the calibration of my Cartesian plane? So I will start with my x using -2. Okay, -2, -1, 0, 1, 2, 3, 4, and shall we say 5. So if I have these values, what would be my y? Okay, so if my y is if my x is -2, this will be -2 raised to the second power minus 3 multiplied by -2, that is 6, that is 4, then that must be 10. Okay, if that is -1 raised to 2, that is +1, -1 multiplied by -3, that is +3, add them, that is the same as 4, and so on and so forth. So if I have 0, 0 is +1, -2. Okay, if I have +2, still -2. Meaning to say with this, because this is parabola, the vertex of the parabola is between this point, 2 points. Okay, down below these 2 points. So if I have 3, I will be having 0. If I have 4, I will be having 4, and if I have 5, this must be 10. Okay, so those are the values of the y, or the function, given the values of x, and replacing that one in our working equation or function x raised to 2 minus 3x. Okay, now we are now ready to graph it. So if I have -2, my y is +10. So allow me to make use of this one. Okay, allow me to make use of this one, -2. Now my point is located in here. Okay, ayan, located in here. Now if I have -1, my y is +4, so -1. I have in here -1, so most probably the point is located in here. Okay, if I have 0, then the point is located in here, and if I have +1, then that is -2. Okay, +1, then that must be -2. If I have +2, then still the y in here is -2, so we have in here. Okay, so that must be -2. Now if I have 3, then that must be 0. So 3 yung x, that my y must be 0. Okay, and if I have 4, then my y would be +4. So 1, 2, 3, and 4. So we have in here, and if I have +5, my y would be 10. So let's try to have, so this one, my y would be 10. So we have in here. Okay, so these are the points. These are the points identified the different coordinates. Okay, definitely our vertex is somewhat located in here, and vertex, the lowest point of the parabola. So in here, so we have in here now, we can now connect. Let's connect our point. Okay, let's connect our points. So allow me to make use of the freehand. So yan, allow me to have the freehand. Yan. So that is my parabola. Okay, so that is my parabola. So again, let's try to redo the coordinates. Let's try to have them. Yeah. So these are the coordinates. Okay, now after having now the graph, you can label the points. Okay, you can label the points, but of course just to we will label that one after the after the plotting. So again, let's try to have our point of tangency is located at point 2 and negative 2, and where is that? Point positive 2 and negative 2. So meaning to say it is located in here. Now another one, our slope, which is the computed one, is 1. So meaning to say, if we are going to have the change of x and change of y, this is the same as over 1. So change of y is 1, change of x is 1. So that if this is our point of tangency, we can count that. We can count. So when from the point of tangency, we count 1 unit upward. Okay, we count 1 unit upward. So we have in here. Okay, so our 1 unit is I have in here, and of course our change of x is positive. From this point, count 1 unit to the right. Okay, from this point, count 1 unit to the right. So we do this one so that at least there is more accurate or closer to accuracy. Our drawing would be closer to accuracy. So using the slope to graph the tangent line, from the point of tangency, the change of y, which is the same as 1, is count from this one upward, and change of x will be this one. So expected, you have in here the point, so that you can now have the tangent line. So our tangent line now would be this one. So notice our tangent line touches the point of tangency. Okay, so this will be our tangent line. Okay, so we say that our tangent line is named as, what's the name of our tangent line? So we have in here, tangent line is y is equal to x minus 4. So the name of this one is named as y is equal to x minus 4. Now, where is the point of tangency? So this is our tangent line. Where is the point of tangency? This one. This is the point of tangency. Okay, 2 and negative 2, which is called to be the point of tangency. Tangency. That is the point of tangency. Now, of course, this one is also now the, what is this? This is already our function, the parabola. What is the name of our parabola? That is f of x is equal to x raised to 2 minus 3x. Okay, so that is the parabola. Okay, that is the parabola we have. And of course, so that we have a better labeling, let's try to label this one as 5 point, what is that point? 5 and 10. Allow me to make use of red ball pen. This point is 4 and 4. Okay. This one is 3 and 0. How about this one? 0.2 and. How about this one? That is the same as we have that point. That is 0.1 and negative 2. This one, that is 0.00. This one, this is negative 1 and 4. This one, that is negative 2 and 10. So those are the labelings of our graph. So I hope you understand the process of differentiation of how to solve for the parabola, or how to solve for the derivative of the tangent line. Okay, so again, the derivative of the tangent line is actually the slope. Okay, it pertains to the slope. Slope of what? Slope of the tangent line, and of course slope of the curve at a certain point. Where is that? What is that point? Point of tangency. Okay, so before I'll say thank you again, may I encourage you to please subscribe. Okay, subscribe and watch the whole video. You share it to your classmates so that your classmate will also understand. And of course, click the notification bell, okay, so that should there be a future posted lesson, you will be notified. Now again, the purpose of this channel is for you, my student, to at least help you enhance more understanding of the lesson. Thank you and more power.